Hi, hello everyone. A big hi to all my dear, super awesome, super great bacha logs. So, this is Ameer, your physics educator at Unacademy. So, in today's session, right, which is the second lecture of our chapter Thermodynamics, do you know what we're gonna do? We will be covering that important topic from this chapter, which is thermodynamic process. Let me say this is so much important, or we can call this as the core of this particular chapter, so don't miss it. I want every one of you to be there from the beginning till the end so that I can promise no one will be having any troubles with the topic of thermodynamic process after this class. You'll find it so much easy. So yes, once again, hi, hello everyone. How was your day? Everyone here in this chat box, update me. Arey Jia, good evening. Cute boy. Selfish Whitey. Hi Jia, Ajay. Cute boy, hi, hello. Arey, wow, so much of energy with a cute boy, right? Okay, मेरा दिन तो बढ़िया था. I'm so happy actually. Super duper था प्रीति. Good to know that. Hi Ajay. Gurugul, good evening. Sumit Tadavi, hello. Okay, बच्चों लोग, a very good hi, a big hi and good evening to every one of you. Now, if any one of you is seeing me for the very first time, a small introduction is given about me on the screen. I have an experience of more than 3.5 years in the field of teaching JEE NEET and a board student. I'm a beta graduate from NIT Calicut in mechanical engineering, and let's say this is all about me. One more thing I forgot to tell you, look, I'm from Kerala, okay? So I'm not so good with the language of Hindi. So what will I say is we'll be having all our conversations, explanation, everything is going to be in English. Remaining things, matlab chotu conversations, all these things we can have in the language of Hindi. Obviously, I'll be making mistakes in the language of Hindi when I speak. Okay? It's totally fine. You can make fun of me also. Moving forward. Now, I'll show you the schedule for this particular week. What all amazing things we are going to do to grab full marks for the term 2 examination. 18th of Jan we are doing the thermodynamics. Next class will be on 20th Jan with the third session of thermodynamics. At least by this class we'll be covering the entire chapter. Arey, ye to second hai. Okay, today we are having second lecture and we'll be having third lecture on this particular Thursday. Okay, numbering mein thoda difference hai. And 21st Jan, not at 8 p.m. on Friday, we'll be having our class at what time? Chalo? You all know. We will be having our class at 10 p.m. Okay, on this Friday, and we are going to be taking a very quick revision of thermal properties of matter. You know this chapter before thermodynamics, right? We'll be having a very quick revision on this particular Friday. Don't miss it. It will be very important, okay, and it will help you to revise the entire concept. I'm expecting every one of you. Okay. Moving on, Telegram. Now, Vachalo, if you don't want to miss the live classes from any of your favorite teachers, the Telegram link is given here and also in the description box. Okay, jaldi se aa jao and join the club. Let's say. Now, Bugs Bounty, what it is? Bachalo, it's an amazing program which can help you to get a lot much of prizes. What do you have to do? You just have to go to the description. There you'll find a form. Fill the form if you are finding any inappropriate content in the videos uploaded by Unacademy. ठीक है? If it's valid, बहुत सारा prizes मिल जाएगा अब सब लोगों को. Now देख ले. Is there anyone who haven't attended Unacademy Combat scholarship test? If you haven't, let me warn you, bachalo, you guys are missing lot much of benefits. Shall I start from the beginning? If you are one among the ranks 1 to 3, what all you're gonna get? Dekh le, first rank gold medal, second rank silver medal, and the third rank bronze medal. I haven't completed for the first 3 ranks. Dekh le, you guys are also gonna get 1 year of free Unacademy Plus subscription. बहुत सारा मतलब gold medals, 1 year free subscription. Don't you think you're gonna get a lot? Don't worry, others are also gonna get scholarship, and for the first 25 rankers, certificates are also being distributed. Okay, so what else is stopping you? And one more thing, if you want to come and write this is absolutely free. You don't have to pay anything, but you'll have to remember this code, mera bachcha log. Then only you can get into this scholarship test for free. What is the code? AMB10. Okay, use it and be a part of this combat test completely for free. Now, moving forward, I want to ask every one of you, okay, to share this class to all your awesome, super duper awesome friends, okay, and tell them भैया का class शुरू होने वाला है, जल्दी से जल्दी आ जाओ. Okay, so tell me how many of you already did that? How many of you have shared that class to all your friends by the time? Anyone? Miara did? Okay, cute boy. with that full of energy, with full of fire? I think you already did. Mera, right? Already shared and liked. Very good, Jia. Okay, Shreya. I think many of you already did that. Those who haven't, this is the time. In the meanwhile, okay, by the time they join, we'll be having 2-3 minutes for them to join. Okay? In the meanwhile, if anyone is new here, I'll be giving a small explanation about what all amazing features you can enjoy. Okay, how amazingly you can learn once you're a part of Unacademy Plus subscription platform. Okay, now bachalo, nowadays we are learning through YouTube, right? Obviously, this class itself is through YouTube. Now, obviously, I do appreciate that. It's a very good thing. But there are some students who would love personal guidance, personal mentoring directly from the teachers, right? They'll feel so confident when the teacher is just behind them and to make the correction whenever they gone wrong, whenever they make some mistakes, right? This can happen once you're a part of the Unacademy Plus subscription, because there is live chat boxes, there is a question box where you can put your doubts and clear all your doubts there. More than that, you can actually directly talk to your teacher through call, okay, through the app itself, and get your doubts cleared. Matlab, you can talk to the teacher. Matlab, the students teacher bonding, which we all are missing nowadays, will be reborn once we are a part of this Unacademy Plus subscription platform. More than that, dekh top educators of the country who is having a very good experience will be there to teach you. With those experience, they'll be telling you what all question pattern you should be expecting, what is the question, what all questions you should be practicing, so that you can make the best preparations for the term 2 examination that is going to come. And more than that, hai na bachcha log, obviously you just need to follow them. Okay, you will be obviously acing in all the examination which you write, and more than that, you will be getting into the colleges whichever you are dreaming about. Then study materials, practice tests, live test series, everything is going to make you super confident. If you go for 12-month subscription, it will cost you 1,250 per month. And if you don't need to pay that much, we have the code. It's AMB10. Use this, get 10% of discount, and be a part of the family. Now we have one more subscription, Iconic. In Iconic, we'll get all the features of Plus some extra features. Just say personal mentor. Matlab, a person will be assigned to you. He'll be there for all your academic activities. And when this person is there, you'll feel so cool, calm, relaxed, and you will feel more interested towards your studies also. Okay? Then light out solving classes, weekly reports, everything will be there so that you can make a very good improvement in your studies. If you go for 12 months, it should cost you 2,333. लेकिन क्या है हमारा पास? हमारा पास तो कोड है MB10. So uses 10% of discount, maximum offers while you make the subscription. And I think this is the best time to make the subscription. पता है क्यों? Because for the 12 months, or if you go for subscription more than 12 months, you'll be given extra 3 months of K12 subscription. और क्या चाहिए? जल्दी से आजा, make the subscription. This is only valid for the first 500 subscribers. If it is over, I don't know, it will be available to you, so don't miss your chance. And 10% extra discount if you want AMB10. Now, one last thing, tomorrow we have a class बच्चा लोग on thermodynamics का NCERT exercises and examiner question. ठीक है, मतलब from this particular chapter what we are doing, don't miss it. You all know how important this chapter is, right? So tomorrow we'll be discussing more number of questions, so it will help you to boost your confidence a lot. So I'm expecting every one of you tomorrow for the special class at 4:30. Okay? And it is completely free, though it happens in the Unacademy app. You just need to use Hamara code AMB10. You can enroll for this special class for free. Okay? Now I think it's time for us to get started. बोल दे प्रीति, म्यारू, cute boy, Devika, Bhumika, Manish, Shreya, Mithilesh, everyone. Just shout out. Okay? Shout out only if you are ready with a pen. Okay? And a book. And if you are ready to learn the second lecture of thermodynamics. Sumad, yes. Ania, Selfish, Ritu, it's Manish. Thermodynamics में भी पढ़ूंगा. वाह, बढ़िया बात है. Okay, so everyone is cute. There we go, pal. Everyone is so much ready, right? Okay, so there we go. Now, what we're going to learn in today's class, like I told you, we'll be talking about thermodynamic process. But can we directly enter into the topic of thermodynamic process? No. Why? Because there are certain terms we must be familiarized with. So, in the first 10 to 15 minutes, I'll be giving you some of the terms, okay, that we'll be using in this particular classroom and in this particular chapter. After we get familiarized with these terms, we'll be starting thermodynamic process. ठीक है? Fine? देख ले. Now, we know so many properties related to our thermodynamic system. Let's say pressure we have, one of the property, volume we have, temperature we have. Okay. Now, we are going to make a very simple classification of all the properties available. Property matlab, it is the physical quantities available. Can we do that? Dekh le. We have the entire properties here and we are going to make a small classification. Properties. Okay. We're going to make two classification to the properties of thermodynamic system. Which are the properties? Okay. And how we are going to make the classification? First thing is intensive property. Okay. And the other classification is extensive property. Now you'll be asking, sir, just tell me on what basis this classification is being done. It's very simple, right? Those properties or physical quantities which depends on the mass, we call it as extensive properties, which depends on the mass. And what about intensive properties? Those properties which does not depend on capital mass M, we call it as intensive property. Can you give me some examples which does not depend upon the mass? Examples. Give me one by one. Pressure, obviously it does not depend upon the mass. Temperature, it does not depend upon the mass. Then we can go with density rho, it does not depend upon the mass. And whatever mass we take, water will always be having a density of 1000 kilogram per meter cube. Matlab, these are some of the quantities or properties of a gas which does not depend upon the mass of it. Clear? Now tell me, extensive ka examples kya aate hain? One by one. Which actually depends upon the mass. First one, yes, volume. Isn't it? Volume, obviously. Then which one is the other extensive property? Can you give me that? Array, the delta U. याद है delta U? Delta U क्या होता है? Internal energy change. So if more is the mass, more will be the number of particles, more will be the internal energy it possesses. So internal energy change depends upon the mass. What about the work done? Obviously, if there is more mass, we have to do more amount of work for the same volume change, right? Obviously, work is also depending upon mass. What about the heat energy? Delta Q we already have learned, that is delta U plus delta W. So if delta U and delta W depends upon mass, delta Q, which is the heat energy, will also be dependent upon mass, right? So this is how we classify properties on the basis of what? On the mass. Clear hai na sabko? Okay, chotu sa classification, chotu sa nanna sa pyara sa classification. Jaldi se note kar le. Okay, no doubts, I suppose it was a direct thing. ठीक है, fine. हो गया तो बता दे. Once you have completed taking down the notes, I can move to the next one. Mass, obviously it's an extensive because mass depends upon mass, right? Note किया ना? Noted. Bhumika, Meru, Preeti, कोई भी doubts नहीं, कुछ भी नहीं, doubt भी कुछ भी नहीं है, note भी किया है. ठीक है, बढ़िया बात है. Okay. Shall we proceed further? Okay, देखिए. Now, next is thermodynamic state variable. Before I give you an explanation, just read the definition given here, everyone. I'll also read, just listen to me. A state variable is a property of a system that depends only on the current equilibrium state of the system, thus do not depend upon any path by which the system arrives at its present state. Some of the examples are internal energy change, enthalpy, entropy and all. Okay, entropy let's not consider for the time being. Okay, we'll talk about what? Internal energy and enthalpy. Okay. How many of you understood what is this thermodynamic state variable? But look, we have so many properties, right? Let's say pressure, okay? Let's say volume, let's say temperature. All these are properties. If these properties are depending only on the initial position and the final state of the thermodynamic system, then we can call it as the thermodynamic state variable. You need more clarity on this topic, right? देख ले, everyone listen to me here. Everybody, I'll explain the same concept by drawing the pressure volume graph. You'll get a better idea, obviously. That's my promise. Now, the system is initially with a pressure of P1 V1. Okay? Now, you are changing to a new value of pressure. Let's call it as P2 V2. How can we make the change? But chalo, either I can make the change like this. Let's call this as the path 1 by which we have changed the state from the first to the second. Okay? Now, I'm going to change in a different path. Let's call it as the path 2. Okay, now I'm going to make a change as say. This is the third path by which I have changed the state of a system from the first to the second. Whatever may be the path followed, whatever may be the path followed, the value of pressure and volume depends only on the initial and the final position. Isn't it? Such kind of properties, such kind of physical quantities, what do we call it? We call it as thermodynamic state variable, which depends on only initial and final and irrespective of the path taken. So examples are pressure, volume, temperature, and obviously internal energy change depends upon temperature. So temperature is an thermodynamic state variable. So internal energy also such. There are so many such examples for thermodynamic state variable. ठीक है, समझ में आ गया? Okay. Now, you'll get more idea na bachcha log when I ask you or when I tell you which is not a thermodynamic state variable. Can anyone give me the answer in your own head? You don't have to even give the answer in the chat box. Just try to give the answer for those properties which are not thermodynamic state variable. Anyone? Anything coming into your head? Just look into the figure. Array, the work done. देख ले, in the first path, मतलब if you are making a change from the state of the system from the first to the second through the first path, what is the work done? Area under the pressure volume graph is the work done, right? So if we go for the first path, the work done will be the area under that, this much. So if we go through the path 1, W1 will be the work done. देख ले, if we follow the second path, isn't the area under that different? Yes. So if the area is different, isn't the work done different? Yes, it is. So obviously here, when we are choosing different path, the area is changing, the work is changing. So work depends on the path. It does not depend upon the initial and the final position. It is depending on what? The path taken. And such kind of properties, such kind of physical properties are not state variables. So those are non-state variables. Which all are non-state variables? First one is work done. Okay. Can I add anything more to the list? अरे देख ले, डेल्टा क्यू का फॉर्मूला क्या है? डेल्टा यू प्लस वर्क डन. डेल्टा यू is a state variable, but work done is not a state variable. It depends upon the path. So according to the path, value of W changes. Yes. So if W value changes according to the path, delta Q also changes because delta Q is dependent upon W and W depends upon the path. So delta Q also depends upon the path. So if it depends upon the path, that will be a non-state variable. So work done, delta Q, all are non-state variables. Okay? Write it. All these are very important. All terms what we are learning now, है ना बच्चा लोग, बहुत important है, because we are going to use these concepts in the explanation of all the thermodynamic process. Arey, everybody already have given the answer also. Jia, Pal, Ritu, Sumit. ठीक है? Now, everyone go through the concepts once and try to grab the idea अच्छे से. In the meanwhile, I'll have a sip of water also. ठीक है ना? I hope you can see the board. जल्दी से नोट कर ले. Adam Feroz, welcome to the class. And obviously, I have a friend in the name of Adam Feroz. Note किया ना? कोई भी doubt नहीं. I hope you revise this concept once. Then we can move to the next one. Noted Anshika, Sumit, Shreya. ठीक है. Okay. So सब समझ में आ रहा है ना? Okay. समझ में आ गया तो what will also be coming along with it? मजा भी आ जाएगा. ठीक है. देख ले. Thermodynamic equation of state. What do you mean by thermodynamic equation of state? Right now, bacha log, we have learned about thermodynamic state variables, which does not depend upon the path, right? Example, pressure we have, volume we have, temperature we have. Those are not independent. Matlab, there exists relationship between pressure versus volume, volume versus temperature, right? And that equation which connects, right, all these state variables, we call it as thermodynamic equation of state. Once again, the equation which connects all the thermodynamic state variables, okay, we call it as thermodynamic equation of state. And in the thermodynamic equation of state, which is that very famous law which we all can remember about when we think about gases. Yes, it is our famous gas law. Which one is it? Ideal gas law formula. PV is equal to nRT. Now, this is the basic equation. And obviously, we are going to learn so many equations of state. Matlab, so many thermodynamic equations we are going to learn once we start with the thermodynamic process. Okay? So, badhiya. This is just a small topic. Now we are just getting familiarized with all the terms that we are going to use in this particular topic. Or kuch nahi. Samajh mein aa gaya na? Okay, now moving on. Now, it's time to enter into our the main topic, which is thermodynamic process. Everyone write the heading thermodynamic process. पूछ ले सर ये thermodynamic process क्या होता है? I'll explain in a very simple fashion. Can I draw the figure and explain you? Okay, देख ले, you'll understand in a better fashion. We have a thermodynamic system. Let's say it is having a pressure of PA, its volume is VA, and temperature is TA. Okay? Now, you are changing the state of this particular system to new values of pressure, let's call it as PB, new value of volume, and new value of temperature. So, a process is being involved here for the change of pressure, volume, and temperature to some other value, isn't it? That process, we call it as thermodynamic process. So what is thermodynamic process? A process which can convert the state of a system from one to another, we call it as thermodynamic process. Can I write the same? What is the definition for thermodynamic process? A process, ठीक है, which can change the state of a system, change the state of a system from one to another. ठीक है, वो process होता है ना, that is simply called as thermodynamic process. Not a big thing to understand, right? Okay, now we have to familiarize with a new term which is called as quasi-static process. Okay, once that is done, remaining things are very easy and you will fall in love with this particular topic. Small thing, ठीक है? देख ले, what is this quasi-static thermodynamic process? I'll obviously be explaining with a small example like we do all the time. देख ले, we have a thermodynamic system. It is having a pressure of PA, okay, its volume is VA, and it has initial temperature of TA. And this system is in thermal equilibrium with the surrounding. Matlab, same will be the temperature for the surrounding also. Now, I want to change the temperature of this particular system to a new value of TB. Let's give some value so that we can understand. TA is equal to 300 Kelvin and TB is equal to some 600 Kelvin. Okay. Now, if I change the temperature of this particular system all of a sudden from 300 to 600 Kelvin, won't the value of temperature be changing so abruptly? Matlab from 300 it becomes all of a sudden 600, right? If this happens, right? If there happens a non-uniform change in temperature or a non-uniform change in the state of the thermodynamic system, will we be able to make a complete analysis of the intermediate system? Matlab, it goes from 300 to 600. Obviously, the system will be reaching at some 400 Kelvin. Obviously, it will be reaching at some 500 Kelvin. If the temperature is changing all of a sudden, will we be able to analyze the system at this particular temperature? No. If we cannot analyze the system at these changing value of temperature during its change from initial to its final value, right? Can we actually make an analysis of the system? No, it is not possible, right? So whenever we have any thermodynamic process, the change in temperature or the change in any state variable should be very, 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 very slow. Matlab, I want to make a change from 300 to 600. First, what will you do? You will make the change from 300 to 301 in the surroundings. So what will happen? This 301 temperature will be induced to the system also. It becomes 301. Now surrounding is made 302. This is made 302. Dekhle, we are making slow changes in the system. Okay, really slow changes in the system so that it will be in thermal equilibrium with the surrounding all the time. And at the same time, we can study the system in its intermediate step also. And do you know what we call these kind of process? We call this as quasi-static thermodynamic process. Quasi-static thermodynamic process. Why quasi-static? Quasi means nearly. The word meaning is nearly. Nearly static. Matlab, in these kind of process, if we observe any thermodynamic variables such as pressure, volume or temperature, you will find it remaining as almost static. Iska matlab ये नहीं है कि the pressure, volume, temperature remaining constant. It means that the change is made very, 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 very slowly. Okay, in very, 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 very small values. Such kind of thermodynamic process, what do we call it? We call it as quasi-static process. Everyone, is it clear? Understood ये quasi-static process क्या होता है? Now, how many of you want the derivation? I think every one of you. Matlab, not derivation, I'm really sorry. How many of you want the definition? ठीक है? Can I write the same? Quasi-static process, right? What is quasi-static process? It is a process where system changes from one state to another very slowly by keeping thermal equilibrium with the surroundings. Okay, so this is the simple definition what you can see for the quasi-static process. Okay, now a process where the system changes from one state to another very slowly, and even during that slow change, right, it will be always in thermal equilibrium with the surrounding. Such kind of process we call it as quasi-static process. If you want, you can just draw this example also, so it will help you understand in a better fashion. ठीक है? Note कर ले everyone अच्छे से. Okay, is everything clear? And if you have any doubts है ना, जल्दी से पूछ ले. So Telegram channel कैसे join करे? अरे, there is a link which is given as in the description. So you just click on that link for joining the Telegram channel. All the notes है ना, I'll be updating there. Okay. So Gurukul, Shreya, Preeti, Jia, Anshika, Myara, everybody noted है ना? अरे किशन हाय तो बोलेगा, जरूर बोलेगा. Everything is clear. अरे Myara, I think you were late today. Meru, Bhumika, Lucifer, Kishan, Shreya, noted along with me. Badhiya. Now, shall we start with the thermodynamic process? From here onwards, you will find it so much interesting because you already know the concepts, but we'll be obviously increasing the conceptual knowledge what we have. Shall we? ठीक है. The first thermodynamic process, isothermal process. Shall we? Just for your own understanding, before we start, just go through the definition. Then I'll be giving my own explanation. Okay. What is isothermal process? In thermodynamics, an isothermal process is a type of thermodynamic process in which the temperature of the system remains as a constant. Matlab, even if there is a thermodynamic process is happening, if we are keeping the temperature of the system as constant throughout the process, we call it as an isothermal process. I'll give you an example. We have a system. Its initial pressure is PA, its initial volume is VA, its initial temperature is TA. A thermodynamic process happened. I'm writing it as TP. TP का full form क्या आता है? Thermodynamic process. It is not universal. Okay, in only my classes. Don't write in your exam paper TP. Okay, according to this TP, you will get essay wrong. TP for my classes alone. Thermodynamic process. Now the pressure changed to a new value. Volume changes to a new value. The temperature is remaining as a constant, or the temperature is made constant in this process. Do you know what do we call these kind of process as? Isothermal. Iso means same, thermal corresponds to temperature. So isothermal, same temperature. Okay? What can we write? Temperature constant. Or kya? Now tell me bachcha log, if temperature constant hai to what will be change in temperature? Change in temperature kitna hota hai? Temperature constant hai. Change in temperature matlab T2 minus T1. Change matlab T2 minus T1 hai na? And T2 will be T, T1 will also be T because वो तो constant ही रहेगा throughout, zero हो जाएगा. So delta T zero होता है. What about delta U? Internal energy change कितना हो जाएगा? Internal energy change. Formula क्या है? Internal energy change का? Yes, it is NCV delta T, isn't it? Yes. Delta T zero we already proved. So delta U कितना होता है? Zero ही होता है. ठीक है ना? इधर तक कोई भी डाउट्स नहीं है ना? कोई भी कंफ्यूजन नहीं है. ठीक है. Now, do you remember our first law of thermodynamics? Right? Now, let's see how the first law of thermodynamics is applicable for isothermal process. Tell me what is the formula? First law of thermodynamics ka? Delta Q is equal to delta U plus work done. Isn't it? Tell me what is delta U here? Zero. देख ले. So, delta Q is equal to work done. इसका मतलब क्या है? Delta Q is equal to work done. Delta Q मतलब heat energy. मतलब ये कि whatever heat energy we give to the system is only used for doing work here, because it is not given to the internal energy, because the change in internal energy is zero. We already have proved in isothermal. So in isothermal, whatever heat energy we give, it is only used for work done. मतलब to move the piston upside. I hope you do remember all the examples. ठीक है? अभी तक clear I suppose. ठीक है? Delta Q will be equal to W. Now, what is the thermodynamic equation of state? क्या होता है? We'll take a fresh page. We know the ideal gas equation है ना? What is it? PV is equal to N R T. In isothermal process, T is a constant. ठीक है? R is already a constant. Number of moles will be a fixed value, matlab a constant. If all these three things are constant, what can we write? We can write the value of PV is K, which is a constant. Or we can write P1 into V1 equal to P2 into V2, because this always remains as a constant. ठीक है? ठीक है? Okay. Now, someone asks you, okay, for an isothermal process, okay, someone is calling your name, okay, A, B, C, someone is calling your name and asking, draw the PV diagram for an isothermal process. So, first draw the x-axis and y-axis, mark pressure here and volume here. Okay. Now, which equation we can use for drawing a graph? PV is equal to a constant. Rearrange kar le. Pressure is equal to a constant divided by volume. Is it bringing some idea about some graphs which we have learned in chotu classes? Y equal to 1 by x graph, yaad hai? Which is the equation for a hyperbola, right? So similarly, P is equal to pressure is plotted on the y-axis, volume is plotted on the x-axis. So how the graph is going to be? Just like y equal to 1 by x. This is going to be the pressure volume graph for an isothermal process. Okay, just like y equal to 1 by x graph. कोई भी doubts नहीं, सब बढ़िया. Okay, everyone, please note down अच्छे से, because all things what we discuss here is so much important. Note किया? One last thing is left in this isothermal process, that is the work done. उसके बाद we'll start doing the problems. हो गया ना सब? Just tell me, is it clear and have you all noted down? Shreya, let's say, Bhumika, Anshika, Piyush, Sincere, Karan, note किया ना? Ajit, Shravan, okay. Okay, everyone, I suppose you all have noted down and I think no doubts are also there. ठीक है? Okay. सर इसको ब्लॉक कीजिए किशन को. अरे किशन भाई क्या किया? अरे किशन भाई, don't do spam, ठीक है? And don't disturb others also. And I don't want to call anyone's name. So I'll give you a general idea. If anyone, if you find it is not an inappropriate messages are there in the chat box, what you can do? Just click on that person's name. ठीक है? A menu will be popping out. Click on block button. So that person will be blocked in your own personal chat. मतलब you won't be able to see that person. What else you want? ठीक है? गायब हो जाएगा. So you can control which all messages you want to see by yourself. देख ले YouTube कितना अच्छा है. Okay, moving on. Last thing what we want to find out is the work done for an isothermal process and equation for that. Can we do that? देख ले everybody. We have the pressure volume graph ऐसे. देख ले, it starts from an initial volume of V1 and it reaches at a final volume of V2. Now, question is to find out the work done. We know how to find out the work done from a pressure volume graph. How? The work done is equal to area under the graph. Area under pressure volume graph. But here, this area under this graph, it doesn't have any specific shape. If it was having rectangular shape, we could have used a formula of length into breadth. If it was having triangular shape, we can use the half into base into height we can use to find out the area. अरे अभी तो कोई भी shape नहीं है, कुछ भी नहीं है. What will we do in this case? अरे, we'll take a small region, है ना? ऐसे, let's say on the x-axis it is corresponding to a small volume of dV, and on the y-axis it is having a value of P. I took a small area here. Do you know what will I do? I'll find out this small area. Doesn't this have a rectangular shape? Yes, it does. So what will be the small area? dA will be equal to the pressure into the small volume, length into breadth, right? This is a small area. Tell me, if you want to find out the entire area below this graph, which operator will we use? We'll use the operator called as integration. If you integrate as a chotu wala area, you will get the total area. And if you find out the total area, what is it going to correspond to? Work done. We already know area corresponds to work done. ठीक है? And from where to where you are integrating? From a V1 value to V2 value. हो गया काम V1 to V2. Now integration बाकी है. Now before we do the integration, can I substitute for P? ठीक है? From where, sir? कहाँ से substitute करेगा हम? इधर से substitute कर ले. P is equal to nRT divided by V. अरे ideal gas equation. Substitute for P in the equation. Do the integration. हो गया हमारा काम. देख ले. P का value nRT the whole divided by V dV integral V1 V2. nRT constant है. It comes outside, right? What remains is dV by V. What is 1 by x dx? Integral 1 by x dx. याद है ना? That is ln x. I hope you do remember. So 1 by v dv will be equal to ln v. So I'm going to write it here. देख ले. This is equal to nRT ln v with lower limit of v1, upper limit of v2. Apply the upper limits and lower limit. हो गया काम बच्चा लोग. nRT if you apply the upper limit ln v2, ठीक है. Now apply the lower limit ln v1. Log a minus log b क्या होता है? Log a by b. So ln v2 minus ln v1 will be equal to ln v2 by v1. So nRT ln v2 divided by, and thus we have to write the simple formula for work done, in which case isothermal process. हो गया काम? क्लियर हो गया ना बच्चा? सब लोगों को क्लियर हो गया ना? Okay, now before we stop this derivation, chotu wala, okay, substitution I'm going to make. Do you remember this P1 V1 is equal to P2 V2? याद है ना सबको? सबको याद है. देख ले, here we have V2 by V1. Rearrange कर ले here. V2 on the left hand side, V1 I'm going to take it in the right hand side. So V2 by V1 is equal to, from here, P1 by P2, है ना? कोई भी डाउट्स नहीं. So substitute कर ले V2 by V1 को क्या? P1 by P2. कर सकता है? और क्या? बिल्कुल कर सकता है. देख ले, this is equal to nRT logarithm P1 divided by P2. Because sometimes in the question, when they ask you to find work done, they'll be giving you pressure values. So you don't want to get confused there. ऐसे कर सकता है. Okay, clear हो गया अच्छे से? Crystal clear हो गया तो those who are crystal clear, just raise your hands in the chat box. Crystal clear होना चाहिए. और crystal से ज्यादा वाला clear, diamond जैसा clear. कौन? Do you know Vivek sir? He teaches zoology on Unacademy. Okay, I have no idea. Yes, Bhumika. Okay, I can't see the hands raised. Gia I can find one person who raised her hand. Or koi nahi. Others are just giving me yeses. I want the raised hand, at least thumbs up or V. Meru, Mithilesh, Devika, Sumit. ठीक है. Gia we have, Babita, Ankit. ठीक है. सबके पास I got so many amazing thumbs up. Now I'm gonna resize the screen. देख सकता है सबको? देख सकता है ना? Preeti, yes. Okay, Anshika, Arish, Ritu, सबको clear है. Now copy कर ले. Just everyone copy कर ले जल्दी से फटाफट. Copy कर ले, very important है. Now in some cases here ln मतलब to the base e है ना? It is to the base e. Sometimes you will be need to use the logarithm to the base 10. How can we make the conversion? Very simple. देख ले, that also I'm writing. That is 2.303 nRT log to the base 10 V2. देख ले, when I have converted logarithm to the base e to the log to the base 10, just multiply it with 2.303. Because in some questions, you will be asked to use this logarithm to the base 10. Use this. Just multiply it with 2.303. काम तो हो गया. Okay. सब ठीक है ना? ये देख ले, area है. We just derived the value of work done by integrating the area. Work तो मिला है. Happy भी हो गया. ठीक है? अब क्या बाकी है? Yes. Doing the questions. कर ले अच्छे से. पहला question is right in front of you and start doing it. Read the question अच्छे से. Okay? And I'll be expecting the answer so soon. Let me see who's going to be the very first person to give me the answer here. Raghav sir, please speak some Tamil. Enna page Tamil. I hope that's correct. Though my accent is really bad. Enna pesano. Okay. जल्दी से आंसर बता दे इसका. Hi Thanu. Selfish Whitey, the first person to give me the answer is, Arey Selfish Whitey, why don't you keep your name? Okay, so that I can call your name. इसमें क्या मजा मिलता है ऐसे Selfish Whitey, वो ये वो jellyfish ऐसे रखने पे. Sumit, very good. Maru C, है ना? Very good. Latash, Gia, Ritu. I'm giving you this time. Okay, not for me to gaze at what is happening in the chat box. Okay, I'm giving you this time so that you can do the question by yourself and give me the answer here. ठीक है, Nancy, Sincere, Ritu, very good मेरा बच्चा लोग. Shall we do this together? देख ले. In an isothermal thermodynamic process, already declared that it's an isothermal process. Initial pressure and volume are given here. ठीक है. Now the pressure of the container is doubled. Find the volume. Okay. We'll write or we'll start from the beginning. What is the initial pressure given? 10 power 6. What is the initial volume given, bachcha log? 3 meter cube. Now, what is the final pressure of P2? It says pressure of the container is doubled. Initially kitna tha? 10 power 6. So finally kitna ho jayega? 2 into 10 power 6. So volume V2 will be equal to question mark. Actually we can do ऐसे, because you know that pressure and volume are inversely proportional. ठीक है? So if pressure become double, volume become half. So initially it was 3, it will become 1.5. You can do within seconds. Else you can use a formula ऐसे, P1 V1 is equal to P2 V2. ठीक है? ऐसे substitute कर ले. 10 power 6 into 3 is equal to 2 into 10 power 6 into V3. 10 power 6, 10 power 6 cancel. This 2 come to the left. It becomes 3 by 2. 3 by 2 is 1.5. हो गया. Okay, and I think it was very simple. नन्ना सा मुन्ना सा प्यारा सा question था. Isn't it? Yes. और क्या सर? बिल्कुल. So ये question कर ले. ये तो बढ़िया question. ये तो बढ़िया question है. For doing this है ना, you need the formula which we have to write. Let me see how many of you do remember. And let me see the first person to give me the answer. Jaldi. अरे पीयूष गर्ग vlogs, thank you so much. ठीक है, इसका आंसर दे दे अच्छे से. Anyone who's going to give me the answer? The first person to give me the answer. कौन है? I just want to read the name of the first person who's going to give me the first correct answer. This graph is not so much required anyway. I'll show you the graph also. Okay. Miara is giving me 2 options, so that is not considered. Ishika, very good Ishika. Awesome. You are the first person to give me the correct answer. Yes, it is option B, which is 14407 joules. Very good. Okay, others, Jia, Meru, Naresh, Piyush, then Ankit. Okay, very good. Preeti. Okay, everybody is giving. We'll do it. Dekh le. The work done by a gas, if 5 moles, number of moles de diye, of an ideal gas is carried by an quasi-static isothermal, matlab temperature is constant at 500 Kelvin to twice its volume. Matlab the final volume V2 is equal to 2 times the initial volume. In this case, what is the work done? Write the formula for work done. What is it? nRT ln V2 by V1. N kitna hai? 5. R value everybody knows, universal gas constant. Temperature is 500 into ln V2 kitna? 2 times V1. So 2 times V1 by V1. अरे V1 तो cancel हो जाएगा. What it remains is ln2. ठीक है, ln2 का value कितना है? 0.693. That though you have to by heart. ठीक है, you have to by heart it because ln2 is the common logarithm which you can find in almost 99% of the questions. ठीक है, or the multiple or the with a power of 2. So this is very much important. Just learn it. So how much it is going to be? So this is 5 5s are 25, 2500 into 8.314 into ln2 0.693. कितना आ जाएगा? You will get the answer as 14407 joules. ठीक है? ठीक है ना? अरे हमारा वो कहाँ है? अरे भाई पेन का, हाँ इधर तो चुप रहा है तू, इधर आ. ओके, नाउ जस्ट टेल मी, इसका आंसर मिल गया ना सबको? आई होप एवरीबॉडी अंडरस्टूड. नाउ समटाइम्स दीज काइंड ऑफ क्वेश्चन विल आल्सो कम. मतलब PV graph will be given and you will be asked to find the work done. Tell me, how can you find the work done? Or just think, tell the answer to yourself in your mind. How to find the work done? PV graph to de diya and someone is asking you to find the work done. You just need to find the area. Okay? So just look into the shapes that is available. Let's say rectangular, circular, or let's say whatever shape is there, just go for it. Okay? And then find out the area of that shape, the area under the graph. That will give you the work done. We know that, right? Sometimes I was telling, sometimes you can expect these kind of question also. Okay, na? Okay. We are moving on to our next question. I think पूरा का पूरा बच्चा लोग नोट किया है. So many अच्छा questions are waiting for you all. Okay. This is one of super awesome, let's call it, super awesome question. Okay. So I want every one of you to try it and get the answer. अच्छे से कर ले. Okay. Just try. Just try. Don't copy from here and there. Obviously, if you type in the Google, answer तो मिल जाएगा. I don't want you, any one of you to do that. I want every one of you in this time to do the problem and get your answer. Okay. Okay. जल्दी से कर ले. अच्छे से नन्ना सा मुन्ना सा पूरा का पूरा प्यार देकर कर ले. Okay. You guess it will be negative. Okay. So go with your instincts and go with what your mind is saying. PT goes with option A actually. ठीक है. Mithilesh option D दे रहा है. Can I tell you the first person to give me the first answer? The first person to give me the correct answer is PT Puran Chandra Mishra Anshika Gupta, second person. Right? It is option C. It is option C मेरा बच्चा लोग. Right? It's option C. अरे Lucifer भी बोल दिया. देख ले. Everybody listen. अच्छा वाला question है. Okay? पूरा का पूरा concept clear हो जाएगा. First, read the question and understand where is a mistake you all have made. N moles of a gas are filled in a container at the temperature T. If the gas is slowly and isothermally compressed to half its volume, volume to decrease हो रहा है, then the work done by the atmosphere is. What is happening to the volume? The final volume is half the initial volume. This is given V1 by 2. Okay. In the case, we are not asked to find the work done by the gas, मेरा बच्चा लोग. The work done by the atmosphere is asked. It is very important. That's why every one of you got the wrong answer. इधर तो ध्यान होना चाहिए, right? Questions are meant to trick you and to get you the wrong answer. Okay, we shouldn't be going with that flow, right? Okay, now let's see how we can do it in the proper fashion. अच्छे से देख ले. इधर तो gas molecules है. ठीक है, because of pressure, the gas molecules on this piston will be giving a force in which direction? बता दे. In which direction? It will be giving a force in this direction. We can call it as force because of gas molecules. At the same time, piston का बाहर, outside the piston, we have air molecules or atmosphere. Atmosphere also has pressure. ठीक है, if it has pressure, won't it be producing a force? Yes, it is called as force produced by atmosphere. We know that we'll be making any thermodynamic process, matlab we'll be moving the piston so slowly by keeping the system in equilibrium, which means the atmospheric wala force, where can I write? Dekh le. Atmosphere wala force Fa will be equal to Fg because system is always in equilibrium, but opposite direction pe hai ya nahi? Hai ya nahi? Okay, so the atmospheric force will be negative of force because of gas molecules. इधर तक सब बढ़िया है ना? ठीक है. Now we'll proceed. देख ले. Because of this atmospheric force, this piston is moving inside. Okay, how I understood that it is moving inside? Because question में बोल रहा है कि volume तो कम हो रहा है. ठीक है. Now the piston has moved to a new position by making a displacement of delta x. Question क्या है? To find the work done by atmospheric force. So write कर ले same thing. ठीक है. Work done is equal to work done by atmosphere is equal to atmospheric force dot delta x, मतलब displacement. ठीक है. Atmospheric force is equal to negative of force given by gas into delta x. कोई problem नहीं. Force of gas into displacement of gas will give you what? Array work done by the gas. Force into displacement, work done by the gas. Now, we know the formula to find work done by the gas. क्या? Work done by the gas in an isothermal process formula nRT ln V2 by V1. ठीक है? देख ले, we all almost have completed. This is minus nRT ln V2 कितना होता है? देख ले, it is becoming half. So V1 by 2. V1 by 2, V1 भी है. V1 cancel हो जाएगा. We'll write minus nRT ln ये 2, I'm going to take it outside, 2 raised to minus 1. Now I just want to ask you, how many of you know this? ln 2 raised to x is equal to x times ln 2. Those who don't know, just write it down. This is very important. ln 2 raised to x or ln a raised to x will be equal to x ln 2. ठीक है? Similarly, ln 2 raised to minus 1 will be equal to this already existing minus into this minus 1 into nRT ln 2. ठीक है? Minus of minus will be plus nRT ln 2. हमारा फाइनल आंसर तो मिल गया, आंसर भी मिल गया, मजा भी आ गया. ठीक है? And that is the reason we have option C as our answer. आ गया समझ सबको? सबको अच्छे से आ गया समझ? बोल दे लूसीफर, नरेश, मैरू, आयुष. Noted in formula वाला book also, very good. बढ़िया बात है. So have a look at it. Whatever topics you have missed, copy कर ले जल्दी से, अच्छे से. अभी क्लियर हो गया? अरे मिथिलेश, म्यारा, भूमिका, very good. Venna clear. Venna means butter. Nowadays people are using a lot of Google so that they can translate Hindi to Malayalam, I suppose. Shraddha, Bhumika, Jia, Sumit, Janvi. Okay, sub note किया. We can do one more problem. How many of you want to do one more problem? एक और problem from this part of isothermal process. बोल दे. किस किस को करना है एक और problem? करना है तो करने का वक्त आ गया बच्चा लोग. करने के लिए वक्त आ गया. ठीक है? आ गया तो आ गया, क्वेश्चन तो आ गया, तो जल्दी से क्वेश्चन करने शुरू कर ले एंड मुझे आंसर भी दे दे. सबको करना है ना? ठीक है, कर ले फिर. क्वेश्चन तो है, दिख सकता है सबको, आई सपोज. कीप इट हियर. Let me the first person to give me the correct answer. Anybody already gave me the answer hai kya? Okay, I have noted the option. I hope you all can see the option also. Anshika, option A de diye. Okay, I haven't declared the correct answer. No one. Everyone is going with option A. Still, I didn't find the correct answer. I didn't find the correct answer. The first person, very good, Naresh, very good. Roman 4E, awesome. Naresh, Roman, very good, awesome. Yes, the correct option is option B. Okay, so shall I give you the answer? Shall I give you the answer? Very good. I'm so proud of you, those two students who gave me the correct answer. देख ले, question क्या है? A thermodynamic system is taken through the cycle. मतलब A, B, C, D, A. It starts from A and it comes back to the same point of A. मतलब ये कि initial temperature and final temperature तो same होता है. So if both of them are same, what is the change in temperature? 0. If change in temperature is 0 है तो isothermal process it is, right? For an isothermal process, we also know that delta U will also be 0. Yes or no? Yes. Now, if that is the case, delta Q का value, मतलब the amount of heat rejected by the gas, delta Q will be equal to, first law of thermodynamics, delta Q is delta U plus work done. So delta Q is equal to work done in this case because delta U का value 0 है. So in order to find the heat value, you just need to find out the work done, and work done can be found out by finding the area under the graph here. ठीक है? So shall we start our job in finding the work done step by step? ध्यान से सुन ले बच्चा लोग. Give it enough time because this is very important. Okay, देख ले. We have the graph here. I'm going to split the graph into 4. A to B, one graph, B to C, another graph, C to D, another graph, and D to D, A, another graph. Then I'll find out the work done in all these different parts from A to B, B to C, C to D, and D to A. Okay, shall we do that? First one, work done from A to B. How will you find the work done? Very simple, area under the work done. Okay, we'll use another color, I suppose. देख ले. Okay, it starts from the point A and it ends at the point B, and here we have a rectangular area. What is the base here? देख ले, from V it becomes 3V, it's 2V. What about the height? From 0 it is reaching at P, so area is 2V into P. So 2PV is the initial work done. ठीक है? Then work done from B to C. क्या है? Work done from B to C. कितना होता है work done from B to C? 0. Why? Because under the graph BC there is no area. I can explain you one more fashion, because we know that work done का general formula P delta V, pressure into change in volume. देख ले, if we move from B to C, the volume is always 3V, no change in the volume. So delta V 0 होता है from B to C. In detail we'll be learning about these kind of process later. For the time being, understand that ये तो 0 होता है. ठीक है? So ये 0 है. Then work done when it moves from C to D. What we have to do? We have to find the area under the graph. How will you find out the area? देख ले, this area. Okay, how much is the breadth here? It is 0 to 2p, 2p into what is the length of this particular part? Breadth it is that, length it is, right? Final value is V and initial value is 3V. So change in volume is V minus 3V. कितना होता है? Minus 2V into plus 2p, that is equal to minus 2 into 2 is 4. Similarly, work done from D to A कितना होता है? 0 होता है. Same as the concept of work done from B to C. Add कर ले. The total work done is equal to the summation of all the work done and plus 2V minus 4PV will give you minus 2PV. And we know that work done is equal to delta Q. Because we have written in the previous page, देख ले, work done is equal to delta Q. Okay, I have written the same. Work done we have found out that will be equal to delta Q, which means the heat energy change. It is equal to minus 2V. अरे ये minus का, what do you mean by this minus sign? When delta Q is negative. Sign convention says if it is negative, the heat energy is being rejected. And how much heat energy is being rejected? It rejects the heat energy of 2PV, and we have the final answer as this. It rejects 2PV. देख ले, in the question also they specify how much heat energy is being rejected. We get that negative side, it means the heat energy is being rejected. आ गया समझ सबको? आ गया समझ सबको? अच्छे से? Okay, I'll just turn the page and show it to you. Copy it down so that nobody will be having कोई भी problem. फटाफट कर ले. Go for it everyone. Heat is rejected, right? Clear? Yes? Okay. Now isothermal process तो हो गया. Now tell me, how many of you have stored enough energy so that we can learn the adiabatic process? एक और process, how many of you have the energy? We'll learn एक और process. How many of you think that? Yes sir, I'm ready to do it. थोड़ा difficult हो जाएगा than isothermal process, but if you are ready है ना, we can do that. Who noted है ना सब? I think everybody have noted. ठीक है. Roman तो ready है, श्रेदा तो ready है. Okay, so Ritu तो ready है, then Bhumika, अरे पूरा का पूरा बच्चा लोग तो रेडी है, ठीक है. देन व्हाई आई हैव टू स्टॉप इवन दो मैं तो बिल्कुल हंग्री है. एक और टॉपिक आई कैन वेट फॉर नेक्स्ट हाफ एन आवर, ठीक है. ओके, वील स्टार्ट. नेक्स्ट टॉपिक, एवरीवन हियर write the heading as adiabatic process. Adiabatic process. Read the definition, everyone. What is given? The thermodynamic process in which there is no exchange of heat from the system to its surrounding, neither during expansion or during compression. मतलब whatever is happening to the system, we are not giving heat energy to the system, nor heat energy is being emitted out from the system. मतलब there is no change in heat energy. So delta Q का वैल्यू कितना होता है, change in heat energy कितना हो जाएगा for an adiabatic process. For an adiabatic process delta Q 0 होता है. मतलब heat energy में change भी नहीं है. क्यों change नहीं है? Because we are having such a kind of system where we don't give any heat energy to the system, where we don't take heat energy from the system also. Such kind of a system, adiabatic. Okay, can you tell me any example for this adiabatic process? कोई भी example आ रहा है क्या आप लोगों का मन पे? Very simple example is there. Yes, thermoflask. Thermoflask is almost made adiabatic in nature because so that we can keep the heat energy and temperature of whatever fluid we fill in that thermoflask, right? Why the temperature is kept constant? Because the temperature, matlab the heat energy is not being released or not heat energy is being given to that thermoflask easily. One of the best example is thermoflask for explaining adiabatic process. ठीक है? Now tell me, if delta Q equal to 0 होता है, how the first law of thermodynamics will be for an adiabatic process. देख ले, we know that delta Q is equal to delta U, which is change in internal energy, plus work done, isn't it? अरे for an adiabatic delta Q 0 होता है. So if I take work to the left hand side, work will be equal to negative of internal energy change. So in an adiabatic process, the work done will be equal to the negative change in internal energy. It's very important. Okay. So this is a simple to note that this is so much important. ठीक है? Okay. बढ़िया है ना? सबको समझ में भी आ गया. ठीक है. Now, how can I express by using the equation of state, okay, and adiabatic process? Because we had PV is equal to constant in the case of what? Isothermal process. Either what is the formula? We don't need to do the derivation, मेरे बच्चा लोग. I'm directly giving you the formula because derivation is not given in your NCERT. If it is not given in your NCERT का मतलब ये कि we don't have to learn the derivation. You itself know that there are so many derivation given in the NCERT which we have to by heart. So इसको जरूरत क्यों नहीं? क्यों? Why we have to take this responsibility over our head, है ना? So just learn that the formula, the equation of state for an adiabatic is PV raised to gamma का value constant. You'll be asking, P and V, sir, we know it's pressure and volume. Gamma कौन है? We are seeing for the very first time. Do you remember CP? Molar heat capacity at constant pressure. Do you remember CV? The molar heat capacity at constant volume. उसका ratio होता है ना CP by CV. वो ratio is gamma actually. CP by CV, वो ratio is called as gamma. ये तो याद है. CP क्या होता है, CV क्या होता है, we already have discussed in thermal properties. I think you do all remember. That ratio is called as gamma. So you can actually write P1 V1 raised to gamma will be equal to P2 V2 raised to gamma. ये भी ठीक है, ये भी सही है. ठीक है, तो ये तो क्लियर हो गया, I suppose. ये भी क्लियर हो गया, I suppose. ठीक है. Two more things are left. One is the graph and the other thing is the formula for work done. जल्दी copy down कर ले and try to think. हाँ, whatever sir has said is understood. ये ऐसे equation क्यों आ गया? ऐसा वाला equation क्या है? गामा का value क्या होता है? And अरे बाप रे, मैं भी भूल गया. अरे इसका नाम तो पूछ ले. ठीक है, नाम तो कोई भी नहीं पूछ लिया. Did anyone ask in the chat box also? Let me see who is those amazing students who asked me the, ये सर इसका नाम तो बता. अरे गामा का एक नाम है जस्ट लाइक मेरा नाम तो खान है, अरे खान नहीं अमीर है, ठीक है। नाउ गामा कौन होता है? गामा इज गिवन अ नेम ऑफ एडियाबैटिक कांस्टेंट। ओके, इसका नाम क्या होता है? एडियाबैटिक कांस्टेंट। ये भी राइट डाउन कर ले, वेरी इंपॉर्टेंट है। ओके okay, we are going to proceed further. What all things are left? One is to draw the PV graph. On what basis we can draw the graph, bachcha log? PV raised to gamma is equal to a constant. So we can write pressure is equal to a constant, the whole divided by V raised to gamma. Just compare it to the graph of y is equal to some constant k divided by x square. How is a graph for y equal to k by x square? Obviously, it's an hyperbola. Okay, so if we plot pressure on the y-axis, volume on the x-axis, how the graph is going to be for y equal to k by x square? As a hyperbolic graph we'll get. Similar hyperbolic graph we are also going to get as a. Dekh le. Now, you'll be thinking, sir, in isothermal process also ऐसा वाला graph था, in adiabatic process also we are getting the same kind of a graph. इसका difference क्या है? What is the difference between them? Can I explain? देख ले. Here there is a power raised to the value of V, which makes the value of V larger here in the equation. If the value of V is larger, the graph will be more inclined towards volume. Now, if it is more attracted towards the volume, ठीक है, what will happen to the graph? Yes, graph will be having a larger slope ऐसे compared to isothermal. मतलब if I draw the isothermal here है ना, the graph will be ऐसे, मतलब slope तो कम होता है, but in an adiabatic the slope will be very much larger. For some questions है ना, we are using this concept. If you want I can draw it here, we'll keep it. ये graph for isothermal, ठीक है, slope तो less है, this is for adiabatic. Difference क्या है? Difference क्या है? Adiabatic has a more slope or large slope. More slope, I don't think it's a good English word to define, है ना? We'll say large slope. Slope तो बड़ा है. For pressure volume graph for adiabatic. ठीक है? Okay, graph भी हो गया. अब बाकी क्या है? अरे बाकी क्या है? अरे last topic. Tell me. बाकी क्या है मेरे बच्चा लोग? Let me see who is going to tell me, because we have derived for isothermal. You might be knowing what is the only topic that is left. Who is going to tell? Miara, Mithilesh, Shraddha, Sena, Preeti, Divya, Divi man, Jia, Nancy. अरे कोई भी नहीं, जल्दी बोल दे, जल्दी बोल दे. What is left? What is left to be found out? Roman is rectangular hyperbola. Yes. Question नहीं. उसके पहले एक और तो करना है. हाँ सुदीप, 11th का क्लास पे. गुड. पीटी रिलेशन कुछ भी नहीं, अरे सब भूल गया. नो वन वाज एक्चुअली लिसनिंग, और सब एक्चुअली वाज लिसनिंग. वेरी गुड आयुष, देयर यू गो. देयर कम्स माय ऑसम स्टूडेंट. आई कॉल दीज काइंड ऑफ स्टूडेंट्स एज ऑसम स्टूडेंट्स बिकॉज दे आर टोटली अटेंटिव इन द क्लास. वर्क डन का फॉर्मूला वी हैव टू डिराइव है ना इधर, बिकॉज nRT ln V2 by V1 was a work done formula for isothermal. ये तो another process है adiabatic. Derive तो करना ही है, करेगा, next page लेगा. We'll do the basic formula for work done. That is integral P dV from V1 to V2. इधर तक it's the same what we have done for isothermal process also. I hope it's clear. ठीक है. Now how can we proceed further? अरे याद कर ले ये. Do you remember PV raised to gamma is equal to a constant? I'm going to substitute for P here. So P will be equal to a constant divided by V raised to gamma. Fine. Substitute kar le the same thing. Pressure is equal to a constant, the whole divided by V raised to gamma dV integral V1 V2. K constant, does it have any job inside integration? नहीं, बिल्कुल. Pull it out, बोल दे आजा भाई बाहर. K. V raised to gamma, it goes up as V raised to minus gamma dV integral V1 to V2. ठीक है. Tell me, integral x raised to minus n dx का वैल्यू कितना है? Integral x raised to minus n, that is x raised to minus n plus 1 by minus n plus 1. Similarly, v raised to minus gamma dv का फॉर्मूला होता है that is k v raised to minus gamma plus 1 the whole divided by minus gamma plus 1. ठीक है, with lower limit of v1 and upper limit of v2. क्लियर? कुछ भी कोई भी प्रॉब्लम नहीं है ना? बाकी क्या है रे, सब्स्टिट्यूशन बाकी है और तो मैथमेटिक्स पार्ट इज ओनली लेफ्ट. ओके, कंप्लीटेड फिजिक्स पार्ट. जस्ट डू दिस रिमेनिंग. That is equal to k divided by minus gamma plus 1. I'm going to write 1 minus gamma. Substituting the upper limit, v takes first v2 whole raised to 1 minus gamma inside the bracket. v2 1 minus gamma minus, it will take the lower limit of v1 1 minus gamma. हो गया? k just multiply inside the bracket. That is equal to 1 by 1 minus gamma k v2 1 minus gamma minus k v1 1 minus gamma. Substitute for k. अरे k का वैल्यू क्या होता है देख ले. k is equal to pv raised to gamma. Okay, and we also know p1 v1 raised to gamma is equal to p2 v2 raised to gamma is equal to constant. It will be corresponding to the same constant. So here for this constant k, देख ले 1 minus gamma, k को क्या कर रहा है मैं, I'm going to give it as p2 v2 whole raised to gamma. k को substitute किया, देख ले p2 v2 raised to gamma. What remains is v2 raised to 1 minus gamma. ठीक है, हो गया, इधर तक हो गया ना. Now substitute for this k as p1 v1 raised to gamma. p1 v1 raised to gamma, v1 raised to 1 minus gamma. I hope you understood. Either for k, why it is p2 v2, why here for k is p1 v1, so that we can simplify at this point, because v2 raised to gamma, v2 raised to minus gamma cancel हो जाएगा. What it remains? 1 by 1 minus gamma. This will be p2 v2, because plus gamma minus gamma cancel हो जाएगा. Similarly here p1 v1. Okay, one of the formula for work done. One of the formula. ठीक है, अभी थोड़ा और छोटू सा नन्ना सा मुन्ना सा ओके एक और सब्स्टिट्यूशन भी करना है. क्या है वे, क्या है देख ले. We know that PV is equal to nRT, right? So P2 V2 will be equal to nRT2. देख ले, 1 divided by 1 minus gamma. This will be nRT2 minus P1 V1 will be equal to nRT. ओके, हो गया काम. I'm going to write nr तो कॉमन है, nr t2 minus t1 है ना. I'm going to write t1 minus t2 by taking negative sign outside. 1 minus gamma, I'm going to write minus of gamma minus 1. Minus minus cancel. Final answer is nr t1 minus t2 by gamma minus 1. ये होता है क्या, ये होता है क्या, बता दे. ये होता है the final formula for the work done. आ गया समझ? देख ले, from the beginning, okay, go through it. Go from each step to another step. Try to understand what is being done in each step. Then only take a screenshot or then only start writing it down. Because ये derivation है ना बहुत important है मेरे बच्चे लोग. बहुत 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 important है. So I'll give you some time, let's say 15 seconds or 20 seconds. This is a formula for work done in adiabatic process. Formula nr t1 minus t2 by gamma minus 1. Once again, it's nr t1 minus t2 divided by gamma minus 1. सर आपको ठंड नहीं ले रहे? आई एम इन केरला, इट्स नॉट सो कोल्ड हियर. इधर का टेम्परेचर इज 32 35. टू लेंथी. हाँ लेंथी तो है, आई डू एग्री विद दैट. बट हाउ मेनी ऑफ यू हैव जस्ट वेंट थ्रू +2 का सैम्पल पेपर्स? इफ यू हैव वेंट थ्रू यू विल बी लाइक बेहोश हो जाएगा इनसे, राइट? बिकॉज the derivations they have asked, it was so lengthy. It was the toughest derivations that is possible from the textbook. I don't know वो क्यों किया ऐसे, ठीक है, ऐसा वाला I was also so amazed, अरे बाप रे, even in this corona situation classes भी नहीं है, ठीक है, and इतना tough वाला questions for term 2, okay, इतना बड़ा derivations. I was also like, अरे बाप रे. Oh nice sir, please take us also there. अरे it is not so good because every climate has its own demerits, है ना. मतलब here तो in the afternoon we'll feel a bit hot here, so okay, screenshot लेना है, ठीक है, okay, I'll move aside. Now you don't need me, है ना. Now people are like, बच्चा लोग सर आप बाहर जा, ठीक है, we just want to take the screenshot. अभी ये हो गया. टेम्परेचर 10 डिग्री सेल्सियस अंशिका, अरे बाप रे, आप लोग कहाँ है, कहाँ रहता है आप लोग, 10 डिग्री सेल्सियस, अरे वाह. Sudeep is like, sir, my number one enemy is thermodynamics. Okay. So हो गया ना ये. So सब बढ़िया है, suppose सब बढ़िया है ना, सब बढ़िया. Can we start doing the problems? Okay. So everyone have a look at what all we have learned in an adiabatic process. First thing first, delta Q का value 0 होता है. Then work done is equal to negative of change in internal energy. Second thing. Third, PV raised to gamma का value constant है. ये gamma is Cp by Cv is gamma. Gamma we call it as adiabatic constant. Then so P1 V1 raised to gamma, P2 V2 raised to gamma. ठीक है? Fine. Now देख ले. Then we have seen the graph for an adiabatic process. It will be a parabolic shape like this. डिफरेंस क्या है आइसोथर्मल और एडियाबैटिक का, डिफरेंस क्या होता है मेरे बच्चा लोग? यस, आइसोथर्मल हैज छोटू वाला स्लोप एंड एडियाबैटिक का स्लोप बड़ा होता है. दैट इज द डिफरेंस. ठीक है. एंड लास्ट थिंग, द फाइनल लास्ट थिंग इज द फॉर्मूला फॉर वर्क डन. वी हैव डिराइव्ड, इधर से शुरू किया, ठीक है. You have, I think you all have to note it down. Okay, practice भी करना है, बहुत इंपॉर्टेंट है. The final formula is nr T1 minus T2 by gamma minus 1. हो गया, ठीक है. नाउ बाकी क्या है, क्वेश्चंस तो बाकी है करने के लिए, ठीक है. रिमेनिंग प्रोसेस विल बी डिस्कसिंग इन टुमारोज क्लास. तो कर ले अच्छे से कर ले. क्वेश्चन तो है, आप सब लोगों को वेट करके. सो अच्छा वाला बच्चा बनकर क्वेश्चंस कर ले. गो थ्रू द क्वेश्चंस, ओके, एंड गेट योर आंसर्स. मेरा गुड क्वेश्चन, दिल्ली में सुनामी कैसे आएगी? राजीव रंजन, में लेट हो गया, अरे बाप रे, इतना तो लेट मत हो जा राजीव. इट्स 1.5 hours लेट, लेट्स कॉल इट. ओके, कौन दे देगा द फर्स्ट आंसर? फर्स्ट पर्सन टू गिव मी द आंसर. एनीवन. अरे सिंपल है, न्यूमेरिकल्स आर एक्चुअली सिंपल. I want the first person to give me the answer. I'll be looking the first person. कौन है? Oh, Roman. Wow, Roman. You always come up with the correct answers all the time. And for the first, very good, Roman. Awesome, very good. Keep it up. Anyone else gave me the answer? Cute boy. Then option A is being given by Tanveer. Okay. Good. There we go. Very good. It's option A, which is 32 joules. Shall we do this? देख ले. A monoatomic gas is suddenly compressed to 1/8 of its initial volume. Okay. Adiabatically, the ratio of the final pressure to the initial pressure is given by gamma का value given by 5/3. देख ले. Gamma का value is given as 5/3. What else is given? Suddenly compressed. मतलब the final volume V2 is 1/8 times initial volume. ये भी दे दिया है. Question क्या है? Final pressure P2 by initial pressure, इसका formula क्या होता है? We can use the direct formula. Which one? P1 V1 raised to gamma is equal to P2 V2 raised to gamma. Substitute कर ले. P1, V1 कितना है? अरे V1 we'll keep it as V1 itself. Whole raised to gamma. P1, V1 raised to gamma कितना? 5/3. ठीक है. P2, V2 will substitute as कितना? 1/8 V1. The whole raised to gamma is 5/3. ओके देख ले V1 raised to 5/3 इधर भी है कैंसिल कर ले. Now P2, I'm taking P1 to the right hand side. We'll have P2 divided by P1. This 1/8 raised to 5/3, when it comes to the left hand side, it will be 8 raised to 5/3. 1/3 मतलब cube root of 8 कितना है? Cube root of 8 is 2. 2 raised to 5 कितना होता है? 32. So P2 by P1 का वैल्यू कितना होता है? P2 by P1 32. सिंपल है ना? देख ले. We simply should be knowing how to deal with the powers. If you know that, हो गया. ठीक है? हो गया काम. आ गया समझ सबको अच्छे से? ओके कोई भी गड़बड़ नहीं. Okay, so हम we'll proceed further. देख ले अगला क्वेश्चन. I think you all have noted down. I'll just show you. Now have a look at it for 1 to 2 to 3 to 5 to 5 seconds देख ले. Okay, and कोई भी doubt है तो you can all tell me. कोई कुछ भी नहीं है तो we can go for the next one. सर थोड़ा story time. अरे वाह. अरे after today's at the end of the session I'll be singing a small song for you because आज मैं बहुत happy है पता नहीं. So we'll proceed further. अगला क्वेश्चन कर ले. अरे छोटू सा नन्ना सा मुन्ना सा क्वेश्चन. छोटू सा नन्नू सा मुन्नू सा क्वेश्चन कर ले. Horror story time of your life. अरे मेरे का मेरा is like sir Malayali song. ठीक है. And who's the first person to give me the answer? अरे कौन है? First person. अरे आयुष. Very good. There you go. Very good. It's option A. And he was actually yelling out. I couldn't see that. Okay. Yes, it's option A. अरे इसमें कुछ भी नहीं है करने को. अरे internal energy change is given as -50. मतलब delta U is given as -50 joule. Question क्या है? Work done during the adiabatic process. Relation क्या है? Work done is equal to negative of delta U. We have learned negative of delta U का value कितना? -50. Minus of minus will cancel. It's plus 50 joules, which is our answer. देख ली? We have done this problem from the basics. कुछ भी नहीं किया और में. देख ले. जल्दी नोट कर ले. And if you have any doubts, let me know in the chat box or else we can go for the next one. Okay. Done. Mithile, sir, as a sincere student, I say today there is no mood to learn. ठीक है, very good. Anyway, I have to complete the syllabus, है ना? There will be so many people who is in mood to learn. Okay, ठीक है. अगला question तो जाने. How many questions are left? Okay, अरे ठीक है, last question है. Last question मेरा बच्चा लोग. आज का last question. उसके बाद हम छोटा का song के बाद we'll wind up today's session. Okay, go for it. This is a very good question also. And I want the first person to give me the answer. Let me see. कौन है आज का अच्छा वाला बच्चा लोग कौन है? Awesome students कौन है? Answer, first person to give me the answer. Arey cute boy. I think cute boy is the first person to give the answer, right? फिर I have Anshiga. Okay, yes, it's option A. I think it is a cute boy who gave me the answer. Cute boy अभी change हो गया. Change कर दिया आपने. It's 5/3 answer. And option A is the correct answer. ठीक है, I'll do it. देख ले, everybody listen, it's a very good question. In an adiabatic process, the pressure P of a gas with the temperature T is P equal to K T raised to 5 by 2. P is equal to K T raised to 5 by 2. Matlab for an adiabatic process, the relation between pressure and temperature is as such. Question is, find the value of gamma. Do you know how we can do this? By making a general formula between pressure and temperature for an adiabatic process. How? Because we already know the basic formula that PV raised to gamma ka value constant hai, isn't it? We don't want V here, we want an equation between pressure and temperature. So substitute kar le V. Kahan se? PV is equal to nRT. So volume V is equal to, okay, N and R are some constant. Okay, let me put it as C into T divided by P. So V raised to gamma is equal to pressure, okay, some constant C, T divided by P, the whole raised to gamma is constant. Here we have a constant raised to gamma. If it goes to the right hand side, that is K raised to some another constant. This will be some another constant. Okay, we'll put it as constant itself. Remaining thing is T raised to gamma. We have P raised to gamma at the denominator, 1P here. What will be the resultant? P raised to gamma minus 1 is another constant. Let's call it as C dash. Okay, just cross multiply. How much will you get? We will get that P raised to gamma minus 1 is equal to, okay, 1 by C T raised to gamma. 1 by C to another constant hai, so we'll put it as a C double dash. Okay, constant will keep on changing to another new constant. That doesn't matter for us. Okay, now we will divide the entire terms ka power with gamma minus 1. Here it will be gamma minus 1. This whole term raised to 1 by gamma minus 1. Okay, this also the whole raised to gamma minus 1. How much it will be? This is P is equal to some another constant K. Let's put it as some constant will change to another, keep on changing to new constant. Okay. Temperature raised to gamma by gamma minus 1. Okay. Now for an adiabatic process, we made a general equation for pressure. For the given thermodynamic adiabatic wala process, we already have an equation for pressure. देख ले, left hand side तो same है. So can't we equate the right hand side? बिल्कुल. इधर का right hand side is some K T raised to 5 by 2. इधर तो it is K T raised to gamma by gamma minus 1. If it has to be equal है ना, ये दोनों तो equally होना चाहिए. मतलब 5 by 2 will be equal to gamma by gamma minus 1. ठीक है. Let's write 5 by 2 का value है gamma by gamma minus 1. Now क्या करना है? अरे क्रॉस मल्टीप्लाई कर ले. 5 gamma minus 5 is equal to 2 times gamma. Okay, minus 5, I'm going to take it to the right. 2 gamma, 5 gamma, that is 3 gamma. Gamma is equal to 5 by 3. हमारा क्या? Final answer. आ गया समझ? Is it clear? सबको अच्छे से? Okay, so go through the solution and go through each and every step. How from one step to another step we have proceeded. Okay, which method sir has used. Okay, and just check you don't have any doubts related to any step. And confirm कर ले ये. Okay. Yes, crystal clear. भूमिका yes. कोई भी doubts नहीं है ना? Okay. Lucifer the fallen angel. मजाक नहीं कर रहे हैं. House is haunted. ठीक है. I am no one to comment on it. मुझे पता भी नहीं है. ठीक है. Related to ghost वो access कर रहे हैं. ठीक है. ठीक है. Okay, so song तो नया कुछ नहीं है. Obviously, old songs will keep on repeating, right? बिकॉज आजकल टाइम तो नहीं मिल रहा है. whenever I get time मैं तो लेजी होता है. I'm not using it for learning new songs. Anyway, I'll sing a chotu wala song for every one of you. Okay? ठीक है. ये मेरा नन्ना सा मुन्ना सा गिटार भैया. Which one? Okay, I'll go with this. शाम सवेरे तेरी यादें आती है, आके दिल को मेरी यूं तड़पाती है. ओ सनम मोहब्बत की कसम. मिलके भी चढ़ना तू दस्तूर हो गया, यादों में तेरी मजबूर हो गया. ओ सनम तेरी यादों की कसम. बसी हो पर दूर हो कहीं, दिल के करीब हो ये मुझको है यकीन. ओ सनम तेरे प्यार की कसम. ओ सनम मोहब्बत की कसम. Okay. Okay, thank you so much. I know that many of you have already listened to this me singing this song, isn't it? अरे मैं तो बिल्कुल अरे भूल गया चश्मा. अरे whenever I forget my chashma, na, please do remind me. Arey, amazing. Thank you, Devika, Naresh, Rockstar. Okay, thank you so much, Mithilesh. Super voice. Preeti. Okay. नया लगता है. अरे Sophia, thank you. Mega, Gia. Sophia is like, whenever you sing, okay, it always feels like a new song. Superb, Gia. Arey, thank you so much. Thank you, everyone. Okay, Jia, Meru, Tejas, Lucifer, Roman, Array, thank you so much. Okay, so more than that, I would be so glad to know that you understood all the concepts that we have discussed, all the questions that we have done in the classroom. That will make me super happy as a teacher. So next time Tamil, Array, Tamil, I want to learn one Tamil song. Rockstar, sir. Array, thank you so much. Thank you so much. Thank you so much. Malayalam song next time I'll try. Okay, thank you so much. Okay, so सबको समझ में आ गया ना, and I hope you all have noted this one also. Now isobaric process and the questions we'll be discussing in tomorrow's class. Okay, now बच्चा लोग offer तो चल रहा है, ठीक है. So मतलब for if you go for subscription for 12 months or more than that, 3 months का extra subscription free में दे रहा है. If you don't want to miss that, you have to be the one among the first 500 subscribers. And along with that, if you want to get 10% of discount, don't forget we have our code है ना, AMB10. Use this code and be a part of this. Okay. Now moving on. Bacha log special class hai kal. Okay, special class happened on the app, and let me tell you, it is completely free. Which topic? Thermodynamics. So don't you want to do lot many problems from your NCERT exercise and examiner? है ना? Don't you want to gain more amount of confidence in this chapter? है ना? So क्यों wait कर रहे हैं? Come and enroll for the special class which is going to happen tomorrow at 4:30 p.m. It is damn important because we'll be discussing so many questions from the topic of thermodynamics. And let me tell to all the बच्चा लोग ये तो free है. Don't think that ये तो app पे है and we have to pay something. No, it's completely free. Now those who don't know how to join for the special class, what you have to do? You just have to download the Unacademy learning app. Fair. Now after downloading, log in कर ले with your credentials. उसके बाद क्या है? Now you have to go to menu after logging in, click on specials, then type down हमारा code. What is the code? It's AMB10. Use कर ले. इतना आसानी से you can just enroll for this course and grab the maximum marks from the topic of thermodynamics. So don't miss your chance. Okay. Now चल रहा है, ये तो already told है. Now Unacademy Combat scholarship. अरे बच्चा लोग, Unacademy Prodigy का program चल रहा है. Now if you want to get scholarship for your colleges and if you want to win a college grant worth up to 20 lakhs, the scholarship test which is called as Unacademy Prodigy is going to start from 23rd of Jan from 10 a.m. onwards. So don't miss your chance. And if you want to enroll for free, ये तो code है, आप सब लोगों को पता है, हमारा AMB10 referral code use कर ले. ठीक है? And more than that, schedule तो है. The students starting from the class of 7th onwards can write the exam. And here it is. Okay. And you can also have a look at other gifts you are going to get for the rank 1 MacBook Air, मतलब Apple का laptop, 2 and 3 Apple iPhone, Apple iPad, Echo Dot, Amazon vouchers, सब है. ठीक है? So don't waste your opportunity मेरा बच्चा लोग. मतलब getting a MacBook Air if you get rank 1, it's not a big task I suppose. ठीक है? Anyone can come and do it, and at least for the rank 100, to rank 100 you are given so much of gifts and Amazon vouchers. You can even purchase some new t-shirts and jeans or watches by using those vouchers. देख ले बच्चा लोग, if you come and join, you can even join my batch, which is Spark batch, which is happening, okay, for term 2. Right now we are dealing with the topic of the kinetic theory of gases. You can join for that chapter, and oscillations and waves are also remaining. You can come and join. Code तो पता है सबको, AMB10. ठीक है, join करने के लिए. Now special classes, I already have told you, and there are awesome features of special classes. You all know. Live chats will be there. Questions tabs तो होता है. Live polls, leaderboard, सब है. ठीक है. So use कर ले. Now thank you so much everyone. Now you all know how to show some love towards your bhaiya, right? क्या करना है? Move your cursor, click on this like button and tell me that and show me that how much love you all have for me, right? How much प्यार है मेरे लिए, ठीक है? Just show me that. And at the same time, you also can subscribe to the channel so that you'll get all the notifications whenever my classes or the classes from any of your favorite teachers happens. Okay? Now, let me say bye-bye everyone. Naresh, Priyansha, Jikal, Miara, Jia, Preeti. Okay, thank you so much everyone. See you all next class, which is going to be on Thursday at 8 p.m. which will be, I think it will be the last session of the topic. Okay, anyway, bye everyone. So bye everyone once again. See you all. Good night.